Hello everyone, welcome to another new session of Tech Athena. For those of you who are new to Tech Athena is a platform where we discuss about new and upcoming technologies. With that, I'm your host Deepthi, and today with me is our speaker Manish Pingale. Just to give a brief introduction, he works in IBM Automotive team. He's an architect, solution architect, and he has 20 years of experience. And trust me, these architects are the I can say the most intellectual or the most knowledgeable ones I have found so far. That I mean that whole team is actually quite knowledgeable because like I work on different industries with one technology. Like they work with multiple technologies but concentrated only on one industry. So he works on automotive industry. So with that, I will give over to Manish. Manish, just let us know a little bit background about yourself, how you have come into this field, and how your experience has been, and yeah, and what all you keep learning.
Yeah, thanks, Dipti, and good morning, everyone, for joining this session in lovely Saturday afternoon. I mean, it's quite sunny in the middle of monsoon season. That's great. So, I'm not sure I'm that intellectual as Dipti mentioned, but yes, it's been 20 years since I am working. It has entirely been in manufacturing industry. I worked on different technologies. I started off with uh, the manufacturing automation as well as other systems. And here I am at IBM for the last 2.5 years working as a senior technical architect. Well, as Dipti mentioned, yeah, I mean, my previous background has been into multiple industries ranging from automotive as well as oil and gas and chemicals, pharmaceuticals, different industries. And I consider myself fortunate enough to have got acquainted with multiple technologies. And that's what I'm doing here, applying innovation, the right technologies for betterment of providing better solutions to the industry. So that's a brief about myself.
Yeah, and Manish, so today, just a brief before you start, what is it you are going to take us through?
Well, I'll be taking you through connected cars, and as I understand, it's a platform where you have diverse kind of topics which are discussed. So I've tried to keep it as generic as possible so that it should be relevant for everyone who are attending.
Yeah.
So additionally, I mean, we will just look at what exactly connected cars are, what is history, what are the drivers, and where we are heading. So that's what
Okay.
we'll be discussing in
Yeah.
this session.
Thank you, Manish. I will now start over the session.
Mm-hmm.
Just hold on. Yes, Manish, we are started now.
So thanks, Dipti. Thanks for this opportunity, wherein you have given me an opportunity to present my point of view around connected cars, and I hope I'll give some enlightenment to everybody who is on the call. So when we talk about connected cars, so what exactly connected cars are? So I might use interchangeably a term connected vehicle, since it is connected philosophy is not only applicable to cars but also to a larger set of vehicles, commercial vehicles. So I might use it interchangeably, but I mean the same thing. So coming back to our topic, what exactly connected car is? So if you look at the definition of it, it says a connected car or a connected vehicle is a vehicle that is connected to internet. Fine. So what do we do about it when we connect it to internet? So there could be a few things which we could achieve connecting it to internet. Like one may think of telling someone where exactly you are as of now in your car, or you may want the service center to know your car has been broken down and share with the service center where exactly you are so that they can deploy the necessary services to help you. Or you may even talk about buying stuff while you are in car. So we normally do it using mobile phones, but you could also do it right from your dashboard of the car. Or it could be something like simply you want to know where you are going and what would be the best way to reach your destination. Imagine you can get a little advice about something knocking sound which is coming out of your bonnet, and you could fix it yourself. Or you may want someone to know that you have a space in your car and you are willing to share it with a small fee. So connected car is all about this and much more. So we'll see that in a bit. So before we get into the modern connected cars and philosophy, so is this connected car a new concept or a new buzzword? So not really. I mean, in bits and pieces, the concept had existed quite some time earlier. Then it moved to passenger cars and the commercial vehicles. So these are two diverse examples, pole apart. So one is gigantic and sluggish, the other one is sleek and fast. Though they have got one thing in common, which is both of them cost millions of dollars. So the necessity is mother of invention, and that's where the people who had invested millions of dollars in creating the mining trucks or Formula One cars found out better way of understanding their or monitoring and controlling their investment while it is in action, and that's where the philosophy of connected car was born. So in terms of mining, the drivers could be environment. I mean, you're looking at hundreds of square kilometers of barren land, harsh environment, and you would want to know, and safety being the utmost importance in mining industry, you would want to know what exactly your vehicle is and how exactly it is performing in that harsh environment. You would want to deploy assistance whenever it is required. Safety, of course. I mean, the collisions. These trucks are very heavy, carrying heavy load. So you would not want two trucks colliding with each other, or you would want to have the improved performance. I mean, if my vehicle is optimally loaded, how is the tire pressure? Is it fuel efficient? All those things. And of course the reliability. I mean, you would not want millions of dollars of investment sitting idle because it has broken down. And that's where they had quite a customized hardware which used to send information back to the control room, where the trucks could be uh, better maneuvered, I would say. And to an extent, we'll see that in a bit, autonomous vehicle or autonomous driving. But to an extent, even mining industry or mining trucks has achieved that. Although the complexity was small, there was no traffic, and they had to negotiate, and it was a fixed route that they have to traverse. But yes, the autonomous vehicles as well was part of that. Coming similarly, I mean, in case of F1, the assistance is more important. I mean, you would want to let your driver know when to take a pit stop, what is the traffic, how is the weather condition, if there is something wrong with the vehicle. Performance, I mean, fraction of second could make winner or loser in Formula One. So you would want your car to have improved performance, or finding out how car performs in different situations and keep on enhancing its experience. Safety, of course. I mean, 350 kilometers an hour, a slightest mistake could cause a lot of accident. And of course the reliability, because you would want to complete the race and keep winning on different tracks. So that is where the connected cars existed in bits and pieces. So why exactly we are talking that in our passenger vehicles now? I mean, what is that that is driving the connected cars? So one is the cost of network. The wireless communication has gone down and its speed has gone up. The electronic, the sensors, the cost has come significantly down, and its size had reduced. So you could deploy it in cars without much of a weight increase within the car, or fix it within the same space. The other aspect is basically about the technology advancements. It's more of AI, I mean, the cognitive part or even the predictive part, which has gone down to the consumer level now. I mean, we look at smartphones, smart TVs, smart fridge, and that is where the technology is heading. And of course, automotive industries are basically trying to survive through the competition, because the buying behavior of people are changing, and that is one of the major factors why this buzz about the connected cars, which is moving into the passenger vehicles. So give you an example, Tesla Motors, it's hardly 15 years old, and if you look at people had lined up or pre-booked their vehicles. I mean, the automotive industry had existed. There are players who are century old. I mean, such attraction, they fail to garner such attraction for their launches. Or imagine Uber. I mean, it doesn't even own a car, and it just provide a service which is on top of the vehicles, and still it has got more market capitalization from the old players. Who knows? I mean, the people are moving more from commodity to experience, and that is where connected cars has picked up attraction, because to survive, automotive industries would have to change the way they are selling their products. It's not the products, but it's services that people demand. So, in nutshell, I mean, coming back to our topic, connected cars. So, as far as functionalities are concerned, broadly you could put them in four buckets. So you have one about related to vehicles, the functionalities related to driver itself. Then you can talk about environment, and more importantly, the economics, which is the commerce which is happening over and above the connected cars. So in terms of vehicle, imagine if you it's basically connecting car, its sensors, and sending all the vehicle parameters back to a connected vehicle hub from where data is processed. So how it helps manufacturers? So enormous amount of data with different conditions, the way vehicles are being driven, would help them find out what are the failure patterns, enhance the reliability of their car, and basically help them provide a better product to the customer. Or they could, I mean, as far as the maintenance is concerned, it's time driven. So as of now, what we have is every 6 months or a year, the manufacturer would call you for a service. Rather, it could be a different model wherein only based on conditions, or you would have predicted certain thing is going to fail, and then you would give that information to your users and then call them as and when required, rather than it being a preventive. It could be a predictive maintenance, or it could be a condition based maintenance. Emergency assistance. So imagine, you understand your car, and once you start getting visibility into how it is performing, and based on the failure patterns that you have analyzed, you could send an alert to user saying, your car is a particular part within your car is going to break down. Find out the nearest station, and that would certainly be a good a better experience for the user. I mean, imagine you're driving for vacation and your car breaks down. So rather than you calling up the service station itself calls you and say, okay, I have analyzed the car is broken down, and this is the nearest service station you have. Either you could reach out, or we can help you get your vehicle there. The other aspect is over the air updates. I mean, if you look at the cars of today, it's as much about software as much as about the engineering and the mechanics within the car. So the logistics which are involved. So if you have to recall cars, get them to service station to update the firmware or put up a patch over and above software. I mean, you could do, if it is connected car, you could do it right over the air. So you don't have to incur the downtime of the vehicles, as well as you don't have to worry about the logistical cost which would come around above that. It also helps fleet monitoring. I mean, for example, something like car aggregators, or even the transporters, or even the bus and the trucks moving passengers around. So it helps you to better maneuver your fleet. You know where the people are, where it is required, who is going to reach where, and you can better allocate your resources and optimize their performance. The other aspect that we spoke about was driver. I mean, as far as driver is concerned, the experience is driven by one, personalization, and second thing is about the cognitive or AI assistant. So imagine, I mean, you're listening to a song on your cell phone, and as you start packing up to go back home, you just start your car, and the infotainment system in the car picks up the song where it was left on your cell phone and starts playing from there. It's a differentiated experience that you have. So you are living a connected life throughout your day. Or it could be cognitive personalization. For example, you are on a vacation, and then your assistant within the car suggests you that there is a coffee shop down the line where you might want to pick up coffee, because it knows that you had been stopping all the way around in a particular restaurant chain, or you had been making payments within that restaurant chain. So this is what the personalization would be. Or it could be advanced driver assistant. For example, it's raining, you're driving, it knows your pattern, that you at a turn you usually drive very fast, and then suddenly a warning comes. I mean, it's raining, the road might be slippery, you would want to reduce your speed. Or it could be even a simplest thing, like TomTom and Garmin, wherein you have uh, um, corner by corner navigation to help you reach your destination efficiently and well within time. Or it could be the other aspect is basically the way vehicle is owned. I mean, instead of buying your car, you could be sharing your ride, or you could be sharing a seat from for reaching from one destination, from your starting point to the destination. So that's where the personalization comes into play. The other part is environment. I mean, you know where your car is. Overlay on top of that the map, which gives you the location within context with around your vehicle. Then you can have routes over that. For example, you are moving from point A to point B. It gives you what exactly is the best way to reach that. Overlay about that the terrain information like traffic and all. So basically, it helps you understand, helps you with a better way of navigating throughout your journey. Weather condition. So if you are driving a convertible, your assistant comes up and says, I foresee a rain few kilometers down the line, you would want to raise your roof. Or it would help you efficient routing management in case of your transporter, so to help the best route for completing all the deliveries. Or it could be geofencing. You would not want some of the cars moving to a different location. And of course, the point of interest. So it knows that you are not traveling from home to office, you are on a vacation. And then because you know you are interested in history, you might be given a notification saying there is a museum around if you want to see, or there is a kind of historical monument that you would want to visit. And these are all things about personalization and the personal touch which you get within your car. And of course, more importantly, it's about commerce. I mean, dealers and suppliers integrated on the platform. So when it comes to after sales support, supplier would usually know when the car is going to fail, or what sort of spare parts do I need to top up, so they can efficiently manage their inventory. Or fuel station integration. So depending upon which fuel you feel, which type of fuel you use, you would get information about the prices and the fuel stations around, depending upon in case your tank volume is going down. or it could be insurance providers who would need information. So, for example, how the insurance is calculated today, is purely based on the age of the car, as well as the overall age of the car and the value of the car. I mean, it doesn't really take into account driver behavior. So if manufacturers start to share that information, some drivers who are driving safely could basically pay a lower premium than someone who is driving harshly. Or it could be a smart city wherein you would want to know where exactly the parking is and then reach to that parking in an efficient manner, or pay your tolls while your car is connected. I mean, opportunities are enormous. Of course, there are some vendors who also allow you to make payments, or it could manage promotions and loyalties. I mean, since you have integrated a lot of merchants on the same platform, you would want to share your loyalty across whatever you buy, or those merchants send across promotions. For example, there are some offers which are available while you are driving through a particular area. Then you get that information while you are in the car. Who knows, you might want to take a detour and make that purchase. So, as I said, the opportunities are enormous. The experience is what people are looking at, and that's where the car manufacturers are heading, providing experience rather than providing a car. And this is what a connected vehicle or connected car is all about. So let me summarize this. I'll just play a video. I mean, whatever we talked about, probably the video would help you visualize this better. So there we go.
Hello, I'm a connected car. I'm safe, clean, and secure. By using information and communications technology, I can talk to my driver, to fellow cars, to the roads, and to others. I'm a minority in the world of cars right now. Only about 8% of cars coming out of factories today are connected in some way. But soon that's all going to change. By 2020, about a quarter of all cars will be online. Most of the technology to get me to talk to other cars already exists, and it helps my driver get from his home to his office more efficiently every morning. I save time and money by guiding him to get from place to place faster, avoiding traffic jams and road hazards, as well as enabling him to work and stay informed on the go. I am more than just a car. With me, my driver is more connected to the rest of the world. I integrate with his mobile phone and other devices to keep him up to date with news, infotainment, and his daily schedule. My driver and passengers can even install apps on my onboard computer to adapt me to their needs. Like on a smartphone, these apps can be anything from maps and parking apps for my driver to email clients and games, or video services for my passengers. If I need to go in for a service or I need any replacement parts to keep me going, I can alert my driver and even book the maintenance appointment at a local garage. My new connectivity technology is moving the boundaries of what it means to own a car. It also means there are still things to be worked out so that owners can make the best choices as to how to maintain me. Like a computer, I have many complex systems that need to be kept up to date to work properly, and I contain a lot of information about my driver that I'd like to keep safe. I also need to be treated with care so that I'm safe from interference with my systems. I wouldn't want anything going wrong while I'm on the move. I am part of a growing network of cars that can exchange information to help avoid accidents and improve traffic flow. The infrastructure I'll need to make the most of my connectivity talents isn't all built yet, but when it is, I'll also be able to talk to things like traffic lights and road signs to find out what's going on. I'll be able to advise my driver about trouble further down the road, as well as unseen traffic jams and speed limits. This will make all of us a lot safer on the road. My connectivity talents means I will be a lot cleaner, particularly in cities. Because I can find the most efficient route, I don't have to stop and start so much. And because I know all the best available parking spots, my driver will spend less time and energy looking for a place to leave me. Connected cars like me will open up a new world of possibilities that will make road transport safer, cleaner, and more secure. It's a future that's only a few years away.
Okay, I hope the video was able to help you imagine the future. And as we talked about the connected cars, the functionalities across the vehicle itself, as well as driver, environment, and the commerce around it. So the question would come to anybody's mind. I mean, what is driving automotive industry to the connected cars? So it's more of experience. I mean, again, coming back to my earlier examples, while the old or the older folks who had been in business for centuries are struggling to keep their business profitable. The others like Uber are making a lot of money because they are providing the kind of experience to the user. So it's not exactly the product that people are looking at, but I mean, the buying behavior has changed more and more towards the experience, and people are very much okay with as a service rather than making that investment. It helps them to keep moving from one service provider to other service provider, giving them a better experience, or in search of the better experience. And that's where the automotive industry is also moving from product to product and services business. So this is just about survival and mitigate the disruption which is happening in the industry. So earlier, I mean, traditionally, how the car industries were looking at their business model. So the focus was on getting newer car models into market. I mean, it is still there. I mean, I'm not saying this is gone. All I'm saying is the paradigm is shifting, the perspective is changing. So even now, the manufacturers are also focusing on getting newer car models within market. The focus is on car. I mean, having the car most safety as well as safe as well as reliable. The core competency is engineering. I mean, you would look at efficiencies in engine, suspensions, as well as other moving parts within the car. Time to market, well, it takes months, if not years, if not months, to get a new product within the market. You would need to build an ecosystem of suppliers to source your part and be efficient. So the kind of just in time or just in sequence kind of concepts evolved just to make sure that efficiency within the suppliers and the OEMs. And of course, the business model is about units. How many units of cars you sold within a year? So that is how your performance is measured. However, came the disruption with the Uber and Tesla. I mean, again, I'm going back to example of Tesla. It's only 15 years, and we are talking about electric vehicles on rides. So with electric vehicles, the engine itself is gone. So the car is more about software than it is about the engineering within the car, and that's where the changes would come. So now the focus the suppliers are looking at is on ecosystems and services, the kind of services they would be providing. So imagine recently Mahindra started a service which is Glide. It's basically their car, and people are ride sharing on that car. So it's basically shift in the paradigm or thinking which is happening in case of manufacturers abroad as well as in India. The core competency that people are manufacturers are looking at is user experience. Time to market is now weeks because since it is more of software driven and agile and microservices based architecture, you're looking at weeks to deliver a new service to the customer. The workbench is basically ecosystems. So you would want the tech partners or even the AI providers or You would have even startups basically getting into bringing up your car, and the focus is on data collection of data and monetizing it, because that is going to be the new revenue stream for the car manufacturers. So why is it so? So as I told you, I mean, ownership pattern is changing. So consumers are willing to try different ownership model, which is namely the pay as you go. So imagine now we have got car sharing and ride sharing. What essentially it means is now the cars or the seats inside cars are better occupied. So the utilization of overall car has gone up, which in turn translates into people are using less cars individually, which would translate eventually into falling market share for or units which are produced by the car manufacturers, and that's where the car manufacturers would need to figure out what is the other way of generating revenue for them. Reinvention again. Tesla, it's only 15 years old. So with the rise of electric vehicle, uh, imagine, I mean, how long does it take for a new player to come in and get established? Who knows? I mean, it's going to be very short time frame. Tech collaboration. So manufacturers are now more open to collaborate with technology companies so that they can enhance their experience. Like cars are getting acquainted with Google Assistant or Alexa or even IBM Watson. AI. I mean, now with the advances in technology, AI is moved to the point of consumption, to the consumer, closer to the consumer. Your smartphones, your TVs, your refrigerators, and of course, you need to have your cars who are AI enabled, and that's where the shift is. I mean, it's more about making sure that your product is utilized, and while the product is being utilized, you figure out how can I the way it is being utilized, how can I monetize that information to the other players. So let's have a look at technology architecture. I mean, what all parts or technology components that enable this entire connected car journey. So first of all, you have to have a car which is basically having a lot of electronics in it, as well as it has got a head unit. So you have engine control unit, traction control system, or anti-lock braking systems. Then it is connected over CAN bus, so control area network. It's a protocol which is used in connecting electronics within car, and talking to telemetry control unit, which is basically the edge device responsible for connecting to outside world from the car. Then you have satellites. So TCU is basically connecting with satellites to marking its car's position, or LTE, or now 5G, the GSM networks, from where you are transmitting that information to the connected vehicle platform, or platforms like or protocols like MQTT or HTTP. I mean, these are the kind of protocols they use in IoT devices. So within the platform itself, so you would have TCU access management. You would authenticate who is connecting, who is not. Now, since you are getting data inside, you have to trust that data. So you're talking about security and encryption kind of mechanism, so that you can trust that information. Once that information is in, the vehicle data is in, you would basically process it through filtering, normalization, whatever algorithms you want to run through before you basically contextualize it with vehicle and driver master data. I mean, this may come from someone who is registering on the platform, or it may come from the dealers, but you contextualize that information against the master data. Then use that information along with some other information which we talked about, especially in terms of environment. So you have got maps, then overlay on that over and above that is route information, or the traffic terrain information or weather layer about that. And even as far as personalization is concerned, you could have the events which are happening within the city, as well as calendar of the person who is driving the vehicle. So all that information is basically contextualized in three planes. So we in IoT sense, it calls digital twin. So you would have a vehicle agent wherein you have all the information about vehicle. Then you have a driver agent. You are basically understanding the driving pattern of that person. Or you're talking about environment agent, wherein you are contextualizing the position of vehicle against the surroundings. So all that is stored within the connected vehicle data platform. And of course, I mean, as soon as you connect something on internet, the more and more emphasis is given on protecting that. So you would want that information not hacked or compromised by anyone. So you would have that security framework around it. And of course, to connect third-party information, you have kind of APIs and gateway kind of a technology. And comes the important part, which is the analytics. So what do we do with all this information which is assembled together? So first is complex event processing engines, which will give, or a rule engine which will give you information. You are braking and you are taking a turn, which means probably you are skidding, or a particular spot wherein every vehicle going through that spot shows some vibration. So there are portals on the road, or it's kind of a hump which is on the road. So predictive analytics. Now you have enormous amount of vehicles traveling in different conditions. So you know kind of failure. You can have ML algorithms to learn about failure patterns and then warn users saying if something is going to fail. And cognitive is about your personal assistant. So vehicle is actually talking to the user. I mean, it's plain English. So although you have got a lot of complexity in terms of software and hardware within the system, I mean, an average person driving the car doesn't care about it. So you have to have a mechanism to provide him, if that experience needs to be given to him, you have to have vehicle talking to him. So we have got speech to text to speech, and dialogue kind of technologies who are helping people interact with the car, and that's where cognitive comes into play. And prescriptive analytics, the way we talked about, I mean, it's environment says it's going to rain, you're driving a convertible, you inform by the driver, well, raise your hood, because it's going to rain down the line. And that's where the prescriptive analytics comes. Or it's about telling you're low on the fuel, and I see a fuel station just ahead a few kilometers. Would you like to go there? Make a change, detour to that particular fuel station. And that's where prescriptive analytics comes into play. So where does the information comes from, and who basically consumes that information? So on the right hand side, if you see, the information is about maps and the news, weather, the social data, what is happening within that city or place where you are in, or it's merchants. Merchants could be different, for example, from coffee shops to someone who is supplier of spare parts, or it could be fuel stations. And even government. So you would want to know information about the road conditions, the detours that laid down by government, and of course calendar of the person sitting inside the car, so that the car gives them a better personalized experience. And who would be consuming the information which you have assimilated across different sources? So insurers, as we talked about earlier use case, I mean, there could be a smart model, the way your premium is calculated, or it could be dealers who are trying to maintain their inventory post sale, suppliers doing the same thing, or even government, as I talked about. I mean, you have a car showing a lot of vibrations at the same stop, multiple cars showing vibration, so it may be a pothole if it is not a hump. So you can share that information to government, or you could share information in case of eventuality wherein uh, government would try to send out notification, I mean avoid this particular area and go to some other area. So that sort of information could be shared with government, or it could be research agencies who would want to know the behavior of drivers, their buying pattern. So that sort of information could be monetized. So in nutshell, I mean it's all about assimilating the information from various sources, and by virtue of the position of the car and the health of the car, you are basically trying to monetize that data so that the other service providers could give you a better experience before you asked for it, and that's where the whole point is. So again, I mean the technologies involved is cloud. So you have got a number of cars who are not driving at the same time, so you would need that elastic infrastructure. That's where cloud comes into picture. IoT, I mean the vehicle information which is being shared over which is being shared. So for that you need IoT, enormous amount of data. So you would need big data technologies. Analytics is the basic crux of the whole experience. Analytics as a cognitive and AI as well. I mean that is where you develop models to provide that sort of experience to the user. Blockchain, especially, I mean if you have multiple merchants and you would want people to share loyalty points across the network, well, blockchain is an example how you could manage it. Or even in case of regulatory information, say for example the car being updated with a particular firmware patch, you could have blockchain recording that information so that manufacturer are sure of which cars they have upgraded, which cars are not. I mean that's how you could use that. Security, I mean it's at core of any connected platform, and API and microservices. So it's basically all IT which goes into it to develop you the connected experience. Well, as far as I mean, few of the areas I would want to make a point about. So, as far as user experience is concerned, I mean, somebody would say, "Well, I get all that information in my smartphone. So why do I need the car to tell me for commerce or how what is the best route and all? Because Google is helping me with that." And that is precisely the point. I mean, imagine while the car manufacturers are struggling to make profitability, well, Android phone piggybacking on that car is providing different experience to the user and monetizing that data. I mean, the Android phone doesn't even have to travel on its own. It's piggybacking on the car. Why not car companies make use of that information themselves? So it's kind of a turf war. Still, I mean, there are two schools of thought when it comes to user engagement. Some say, well, we'll have some technology like Smart Device Link, which was basically an initiative by Ford, wherein you could connect your mobile phones to the car infotainment system. So, I mean, relevant data from car is also shared to the application on the cell phone, as well as your cell phone applications could be run in the car infotainment system. Driver to that is basically the number of cars sold is much lesser than the number of smartphones sold. So you have developer community which is much more have got more incentives to develop mobile apps than car infotainment system. And to augment to that, basically each individual car manufacturer would have its different technology when it comes to platform of infotainment. So it is not a very lucrative a proposition for the developer community. So you wouldn't have people doing it like they do it for the App Store in Android or Google. So so that is what is the driver behind it. Or I mean, on hindsight, you lose the control over experience and the control over monetization of the data. So Suzuki and Ford are few of the examples who basically do that. The other school of thought is it's basically developing your own custom infotainment system. So OnStar Go was the first one to coin that, wherein you have got OEM coming up with it infotainment systems. Then you would have SI partner who is basically managing your information and data for that, and you had the entire merchant ecosystem connecting over it. So I mean, the way OnStar started for General Motors is they wanted to provide an experience wherein if the airbags get deployed within the cars, the information would be sent to the relevant authorities so that they could mobilize support quickly. And from there, they went on to develop a completely customized infotainment platform which has got entertainment solutions, as well as they have got merchants and the petrol stations, as well as insurance integrated over that, and even managing the loyalties and the restaurants over that. uh, Challenges are basically to create that network around, which is first and foremost. Second thing is it's very cost heavy. I mean, you would have to have a lot of initial develop cost which is going into developing that infotainment platform. And but well, it pays off because it gives you control over the experience provided to user, and it gives you alternate streams like monetizing that data, whatever you have created for that customer. And that's where it's kind of a tough war between the manufacturers and the mobile industry, which you would see. Uh, so the next logical progression, I mean, we talked about the connected cars. So what would be the next logical progression of that when it comes to providing user with the experience? So it's about autonomous driving, which is picking up pace, and uh, even before that, it's advanced driver assistance system. So you basically help driver navigate through, providing him information and how he should act in a particular situation. So there are certain levels which are involved here. So level one is basically mostly all the functions are done by the driver itself, and very few functions which are I mean offloaded to the system. Level 2 is about automated lane changes, as well as steering and acceleration. Everything is handled by the car. However, although the consumer would have his hands off the steering wheel, but he has to keep eyes on, and he has to be alert. So level 3 is basically hands off and eyes off, wherein well, you can watch your mobile phones while driving, while the vehicle drives itself. But in case of eventuality, it may give you a warning wherein you have to basically come back and take control of the car. Level 4 is hands off, eyes off, as well as mind off. I mean, it's towards a situation wherein I mean, the ideal situation experience you would have as much as possible. But then it may not be acceptable. I mean, there are regulations which have to be formulated by governments until such experience is provided. And level 5 is like you just sit in the car, tell it about destination, and sleep and relax. That's what it is. I mean, the kind of experience, it is not about whether it is possible. Yeah, it could be very much possible, but then it costs a lot. So while normal car which is being somewhat automated cost you X, well, level 4 or level 5 it's basically logarithmically high. So unless and until that technology is provided at an affordable price, well, it is not going to be adopted. And of course the other regulatory aspects are there. So what does it take for you to have an automated car or autonomous driving car? So it has got a lot of sensors in it. So it has got cameras, it has got lasers, lidars, so marking the topology around it, or it has got radars who are basically sensing the traffic around it. It has got proximity sensors and everything. So imagine, I mean, all this information, um, within a few hours, the kind of information that is transmitted that by that vehicle may go in terms of terabytes. So it is that much of information that needs to basically processed for an autonomous driving and advanced. Basically, for autonomous driving, advanced driver assistance system could be different levels as well. But then that is what the kind of information that we would want to process, and that's where you could imagine the cost which is coming into play, because you would have to have a system on board that takes care of that, collecting that information, probably storing it, and then sending it across the network. So and then probably getting more and more advanced algorithms back into the car. So this is what the kind of sensors look like if we are talking about autonomous driving. So let's understand. I mean, what are the challenges which are involved in here? So if you have a car, the challenge is about understanding the topology. I mean, you have different countries, different ways on the side of road. The way you travel, you have got multiple languages. The signboards are completely different. So you would want to have a car which is much more generic, recognizing where it is. Depending upon that, it would need to figure out how do they read the road signs. And of course, there are countries or wherein the traffic behavior. I mean, the way people follow norms, the way they drive. Uh, so that is also an important aspect. So training the vehicle to understand the surroundings, decipher the surroundings, and take action is the biggest challenge that you would have in autonomous driving. So of course, I mean, it cannot be achieved by normal rule-based engine. If else, then I mean, it would take conventional system. It would take tremendous amount of time and huge code, and it's impossible. Even the way visual analytics works, the conventional systems, it's hardly impossible to give that experience or make autonomous driving happen. So you would basically be relying on the neural networks. So libraries could be TensorFlow, PyTorch kind of libraries you would have. Uh, as soon as you get into complex neural networks, you are a bit slower in terms of processing, because you need a huge processing power. The way we talked about, I mean, we are talking about terabytes of information within an hour that needs to be processed and deciphered. So, so you need a very efficient compute system. Uh, Usually it is handled by GPUs. So GPUs is basically our encounter with GPUs was more initially about the gamings. I mean, it would give us the hardware acceleration to the way the game was rendered on your screen. So those GPUs who are very efficient in number crunching are basically deployed within your the learning system. And of course, I mean, it's not a serial learning. You would have it distributed learning, multiple GPUs connecting to each other, talking to each other to divide the work and provide the results. So that's how the information is basically the models are developed, the neural net models are developed. So once it is developed, I mean, it's not possible for someone to every time car sending data to the cloud and then it sends back the information. So there is a car in front of you or there is a pedestrian. So it is not possible. So you would want to deploy those AI algorithms back into the car itself. So decision is taken at the edge, and that is where the edge computing comes into play. And even, I mean, you cannot have car every. I mean, as you keep on updating your algorithms, you would want to over the air transfer the new algorithms back to the car. So you would need something like FPGA handling that programming and uh, basically running those models. So it's basically field programmable gate array running the logic for you. The other challenge that the car manufacturers face is basically getting the training data. So imagine, since it's a neural net algorithms, so the more and more data you feed into it, the better and better the algorithms get into picture. So for example, you have 10 cars on the street. You would want those 10 cars, whatever experience they record, save it, transmit it to the central hub, which is basically training the models, and then send an updated model back to the car. So you would need some storage as well within the car to store that data and transmit it over the network. Again, I mean, the transmission itself has to be more efficient because you are talking about TVs and GBs of data being transmitted to your learning hub, and that's where the technologies, the transmission as well as storage technologies would come into play. And the other challenges are basically tagging. Say, for example, before I start training my algorithms, I would want to say this is a car, this is a truck, this is a road sign for stop, this is a road sign for left. Well, I take a picture, I do it for one picture, but then we are talking about a complete stream of your travel. So you would have a lot of people, you would have a lot of that information being available to you. So auto tagging or automated tagging of that information is what would help you in quickly training the algorithms. So those sort of technologies which are involved in autonomous driving. So finally, I mean, coming to an end, see, I mean, traveling is a basic characteristics of human being. I mean, since our existence, we traveled on foot, we boarded animals. When the wheel was invented, we traveled in chariots and carts. All along the driver for the invention was better experience while you travel along, and that's where towards end of 19th century what we had was the first car. When the internal combustion engine was first developed, so we had cars looking like bicycles were first driven. Then in between we have cars which were hand cranked as a starter. It's a century since then, and we see highly sophisticated cars like Tesla. And again, I mean, I'll emphasize this: it's only 15 years old company, and still it has got a lot of market attention. Tomorrow, who knows? I mean, it might be flying cars, or there won't be cars at all, or it may be a completely different form of travel that we had been using. But one thing is for sure, I mean, it's basically the experience which is going to drive the adoption of technology as well as the way people make their travel. And that's what is every auto manufacturer has realized, and that's where we have stepped into the era of connected car. Well, the future is yet to come, and definitely it would be more fascinating. So thank you everyone for patiently hearing me, and I hope I was able to give you some insight about the topic of connected cars today. So thanks,
Yeah,
Dipti.
hold on. Yeah,
Thank you.
yeah. So, Manish, we are now on the Q&A screen. Okay.
Sure.
First of all, it was a very good session, very informative. The reason why I used that your and told that your team is intellectual is something what you have delivered in this session tells. See, like for example, I come from a store. I work on storage. Okay, I only see the complete technology, but you are the one who sees how your automotive industry works, and you relate this to that. Okay, so
Okay.
learning just technology alone is not enough. It is important how and where it is used, and how you can tune to use it. And I feel that's where your team or your intellectuality comes into picture, and where you connect us with that's my thing. And yeah, especially the example when you told, right, how Android is cashing in using the car dashboards, while the car manufacturers are not cashing in. So yeah, that was actually a connect which no one would realize. Only the person who are actually in the automotive industry would know that. Manish, I have one question. Uh,
Hmm.
Being from the server and storage background, okay.
Hmm.
Tell me, the tomorrow the future cars are going to have a server inside them, or will it be a huge one? Is there going to be a GPU inside the car, or a storage? Because I and yeah, my next question comes once you answer this.
Okay. Sure. Yeah, definitely. I mean, as I told, as we talked about, the AI is being taken closer to where it is consumed. So you would definitely need a GPU to process information. So, for example, currently we are relying on the say autonomous driving cars. So we are relying on sending that information back to the central repository where the model gets evolved and model is deployed. So there might be scenarios wherein you would have a more efficient compute power which is available at a lower cost and much more compact, which could be fitted in the car. So why not? I mean,
Okay.
in future you would
So
have GPUs as well on the car.
So do you think it will be as a server will be sitting at the back in a dicky, or will it be near the cylinders? So a lot
So
of our storage space will be gone out.
no, not really. So, for example, I mean, see, what impacts is the connectivity. So, for example,
Hmm.
we are talking about 5G connectivity now. So, you don't need to carry burden of everything to with you. So, it may be it purely depends on what functionality you would want to achieve within the car. For that, shorter training cycles are required. You would have that inside the car, but
Okay.
of course, because the networks are more efficient, you would send it back to the central storage and cloud, the information where it gets largely processed. So,
Okay. Okay. So yeah, and I feel if you are sending all the data onto the cloud, majority of the data onto the cloud, then the network will have to be really, really very good. And I'm not sure. I mean, I think networks also have to grow a lot, especially in India. I know they have to improve a lot so that we get there, right?
mhm.
I see a lot of dependency on network here.
Yeah, to an extent, yes, connected car, but that doesn't hinder. Say, for example, the cars which we are driving as of now are not autonomously driven. So you would have
Hmm.
still people
Yeah.
riding the car. So they can accumulate that information and then send whenever the connection is available. That is one.
Okay.
Second thing is, in case of autonomous driving, well, you would need a lot of network bandwidth to transfer the sensor information, but then that is only required for training the model. Once the model is trained, you would basically send it back on FPGA or GPU where it actually executes or runs. So that is where you don't need to send a lot of information back to even in case of autonomous drive
And
cars.
yeah, I'm talking actually only on the connected cars. Autonomous driving, I don't know when it will come to India. At least, if someone can do autonomous driving in India, I think that will be the best performing autonomous driving car across the world. That's what I think so.
Yeah, don't worry. I mean, all countries are evolving in that. First of all, it's not cost efficient. Second thing is, even if it starts, it will start from the highways,
Hmm.
and where the traffic is much more streamlined and it's much more disciplined. So that is where it would start. And
And
of course, I mean, we hope we will have a lot better infrastructure when the autonomous cars are available.
no,
So
I see a good use for autonomous driving, rather autonomous control of vehicle. from in farming technology, and maybe then it might move on to cars actually, especially in India. But yeah, farmers have to be educated for that, or the farmers have to learn that much of technology to be able to control that.
Yeah, that's right. So that's where the cognitive piece comes into picture. So it's basically simplification of sophistication. So as far as the connection with the farmer is concerned, it's still the way he naturally speaks. The cognitive engines at the back end would handle all the complexity. So yeah, we have got technology. So shouldn't be a major change in the way farmers operate now.
And another thing which is, you are told, right? I mean, for maps, for traffic and all, we have to be aligned with government. So, have you seen in cases where is government really aligned towards getting this done? I mean, getting enabling you or car manufacturers in doing this?
Well, as far as traffic and all is concerned, someone like Google,
Hmm.
so it does not really.
Involve
Uh,
government there.
so it's more about how the fellow mobile phones are
Ah,
performing. Based on that, it figures out how the
okay.
traffic is. So it's not the way a kind of direct probing, but it's indirectly it finds out. But again, answering to your question, yes, because government is much more important here. They have got a lot of infrastructure in terms of cameras, which could be helpful in figuring out the traffic, the congestions. So over the period, yes, the government would be willing to share at least the insights into how the traffic situation is, or the way the vehicles are moving within an area. So
Okay.
they are important. Yeah.
Yeah, I'm sure because the more and more they become open, I think they'll also get more control over the systems. That's what actually government looks for. uh,
Yeah, please.
Another big aspect I see here of all this technology coming in is the security. Okay, I feel there'll be our, I mean, to be starting with, at least when we start with the technology, there'll be lots of hacking and all that will be happening. But yeah, there'll be mistakes that will happen. There will be people who will face, but of course, I mean, there won't be much of a impact. But yeah, if someone hacks, all I mean, they can change your drive pattern, I mean drive way, or you can they can affect the way you drive. And yeah,
Mhm.
which will actually affect a few lives, right?
Yeah, definitely. I mean, even a single life is very much
Yes,
important.
yeah.
So the way we call it, to err is human. But when it comes to technology, the government regulations are stringent. It doesn't allow you to err. So the humans are fine, but technology can't err.
uh,
So that is one.
yeah.
Second thing is, anything which is put on internet is prone to hacking, and that's where the security is of utmost importance. So when we call about IoT and sharing data over network, we would want to have very stringent encryption and PKI to
Yes.
make sure that who you are talking to. The second thing is, as you talked about, could the cars be hacked? Yes, they could be hacked, because I remember reading a news article wherein someone hacked into an airplane and make a few maneuvers
Hmm.
on its own. So that's scary.
Yeah.
So imagine you are on a highway where huge traffic traveling at 100 kilometer per hour, and then one car suddenly decides to stop in between. I mean, it would be a catastrophe. So um, so you have to have security
Yeah, I
infrastructure.
mean, they need to plan something like some kind of backup. If such a thing happens, how do you control it? How do you stop it?
Yeah, definitely. Yeah, security is a
uh,
vital
yeah,
aspect in connected car technology.
I feel as technology is evolving, security has to evolve double the times to cater to it. Otherwise, it will be very difficult for us to manage things or even to live with it.
Yeah, that's true. So they say the policing infrastructure has to be two
Hmm.
steps ahead of the hackers.
Yeah.
So that's how we'll have to address this situation.
Yeah. let me see. Yeah, we haven't got really any questions. I think everyone is learning connected cars now, because connected cars is a new technology which is coming up. So, so it was a very good session, Manish, and thank you for all the details. And before going, first of all, to all the viewers, please do subscribe to our channel. And if you have more questions, please send in a mail to tekatina@gmail.com. Yeah, you can see our email address below. You can reach us on YouTube also. You can leave a message there. We are constantly monitoring it, and we are always there to answer your questions. And before leaving, Manish, the question which we ask every speaker: what is the book
Mhm.
you are reading?
Okay, so it's an old book, so written in 1950s. It's 1984 by George Orwell, which is my recent read that I had. I was I knew about the book, but I was a little late to read it. So
Okay.
it talks about again, it's about connected infrastructure. It talks about that. So I
Oh,
mean, it has been always fascinating to visualize how the future would be, and somebody in 1950s visualized how the future would be. It's
okay.
about you are being constantly monitored and brainwashed to do certain things and to behave in certain manner. Uh,
Okay.
Although it's not exactly what is, but as of now, but then I would say it is what is happening in a different aspect. I mean, look at the way Google and Amazon, I mean, they know me better than myself. They know where I am going, what I am buying, so all that stuff. And if you have a government which would make use of that information, they can really basically maneuver you
Hmm.
in doing something. So it's very much relevant in today's,
Okay.
finding out how it was imagined in 1950, and is it really happening now? Yes, it is really happening. So it's scary.
Okay. So yeah, initially when you told me about this book yesterday, I thought it's some kind of historical book, but now you tell it's a technology book. Okay, I'm geared to read it now. Thanks for letting us know. Yeah, it was an interesting thing to know about you. So guys, that's it for today. Do reach us out if you have any questions. And thank you for your time today. And thank you, Manish.
Thanks, Dipti. Thanks a lot. Thanks for providing an opportunity. It was pleasure talking to you, all of you. Thank you. Have a good day.